feature engineering, where data becomes intelligence. Most people think machine learning is about models, algorithms, neural networks, complex architecture. But the truth is, models are not where intelligence is created. It's before that. It's in how you shape the data. And that process has a name, feature engineering. Now, this is one of those concepts that sounds technical, but once you understand it, you realize it's actually very intuitive. Feature engineering is simply taking raw data and transforming it into something more useful. That's it. You're not changing the model, you're changing the input, and that changes everything. Let's slow this down. Imagine you have a data set. You have age, income, education, health matrices. These are raw features, but raw data is rarely perfect. Sometimes it's messy, sometimes it's incomplete, sometimes it doesn't capture the full picture. And this is where most people go wrong. They take raw data, feed it into a model, and expect intelligence to come out. But intelligence doesn't work like that. You have to shape the input. You have to think about what matters. For example, instead of just using age, you might create age groups, risk categories, normalized values. Now, the model doesn't just see numbers, it sees structure, it sees meaning, and that improves everything. This is feature engineering. Now, let's go deeper. Feature engineering is not just about transformation, it's about representation. How do you represent reality in a way that a machine can understand? Because machines don't understand context, they understand meaning. They only understand numbers. So you have to translate reality into numbers. And how you do that determines how your model performs. Let's take a simple example. You have a column called city. To a human, this is obvious. But to a machine, London, Paris, New York means nothing. So you encode it. You turn it into numbers, maybe one hot encoding, label encoding. Now the model can process it. But here's the key, different encoding methods lead to different results. And that's where your thinking matters. Not the model, you. Now, let's talk about scaling. Some variables have large ranges. For example, income 20,000 to 200,000, age 18 to 80. If you feed these directly into a model, one variable might dominate, not because it's more important, but because of its scale. So you normalize, you bring everything into the same range. Now the model treats variables more fairly. Again, this is not model intelligence. This is your intelligence shaping the data. Now let's connect this to AI more broadly. Everyone talks about AI getting smarter, but a lot of that intelligence comes from better features, better representation, better input. Because if your input is strong, even a strong model can perform well. But if your input is weak, even the most advanced model will struggle. This is something beginners don't realize. They chase complexity, but real power comes from simplicity, done properly. Now let's take this further. Feature engineering is also about creating new information, not just transforming existing data. For example, you have weight, height. You can create BMI. Now you have created a new feature, a more meaningful one, and that can improve your model significantly. This is where creativity comes in because feature engineering is not just technical, it's analytical. It's about asking what information is missing, what would make this cleaner, what actually matters here. And those are human questions, not just machine questions. Now, here's something important, feature engineering is where bias can enter because the way you transform data reflects your assumptions. If your assumptions are wrong, your features will be misleading and your model will learn the wrong patterns. So again, understanding matters, not just processing. Now think about automation. Some modern AI systems automate feature engineering. They generate features automatically, but even then, they are still working within rules, within structure defined by humans. So the role doesn't disappear, it evolves. You move from manually creating features to guiding the process, to validating it, to questioning it. And that's the real role of an AI practitioner, not just building models, but understanding the system from input to output. Now, let's connect this back to your mindset. Future engineering teaches something deeper. It teaches you that how you frame a problem changes the outcome. If you represent something poorly, you get poor results. If you represent it clearly, you get clarity. And this applies beyond data. In thinking, in communication, and in decision making, the way you structure information shapes how it's understood. So, feature engineering is not just about data, it's about perspective. It's about shaping reality into something meaningful. And that's where intelligence starts. Not in the model, but in how you see the world and how you represent it. So, next time you work with data, don't rush to build a model. Ask yourself, what am I really giving this system? Because whatever you give it, this is what it will learn from, and that determines everything.